Okay, so today we're going to be talking about the magnetic force on a proton or a electron traveling through a magnetic field. So when you have a magnetic field, it's either going to be an X. So if you see something like this, it means that it's going into. And then when you have it like this, it means it's coming out of, so it's coming out at you. So in today's demonstration, we're going to be using the one that goes into, just because it's easier to maneuver your hand. So we're going to be talking about the right hand rule. And the right hand rule is basically a little helper to help you figure out in which direction the force is influencing the proton or the neutron not the neutron, the electron that is moving through this specific magnetic field. So it's called the right hand rule. And this comes in handy when you're trying to figure out in which direction the force is. So say you have a magnetic field and it's going into the board. So this is the direction of your magnetic field is going into. So your fingers or your fingers are going to be pointing into. And then let's say we have a proton and it's just traveling and it's going in velocity towards the west, which would be your east, my west. And that would be your thumb. So you have your thumb is moving in the velocity of the proton and your fingers are pointing into. So that means that the force is downwards. So you have your force of your proton is going down here. Maybe I'll do that in a different color just so you can see. So this is the force. So blue is going to be force. And purple is going to be velocity. Or speed. So it's a little easier. So, maybe you haven't gotten that yet, so we can use another example. Let's see. Let's say you have a magnetic field, but it's coming outward at you. Let's do that one, because that one's a little harder to maneuver your hand with, but we can still work that one out. So this is your magnetic field coming outward at you. I think it should be little dots, but we're going to do circles so that it's easier to see. So we have that magnetic field, and now we have we're going to do a proton just because it's easier for now. So that's a proton, and its velocity is pointing, it's pointing downwards. So your velocity of your proton is downwards. So you're going to have the magnetic field coming out and your thumb going down. So it's going to be like this, and it's going to be like this. Wait, does that make sense? Yes, it does. So it's coming out, and this is the velocity, and this is the magnetic field. So the force is going to be to the right, or my right, maybe your left. So let's see, it's going to be this way. So the force is going towards the east, which would be your west if you were watching this. So now that's a little easier because we are using a proton. But what if we're going to change the direction of the magnetic field, and then we can do two examples of an electron. So let's see, you have an electron. It's going into a magnetic field. You have your electron. Here's your happy little electron. And this velocity is going upwards. So now for electrons, instead of using the palm of your hand, you're going to do the back of your hand. So it's going to be the same thing. It's your fingers are pointing in the direction of the magnetic field, which is going to be into the board, and the velocity is going to be going up. But instead of having the force coming out of your palm, it's going to be coming from the back of your hand. So now, instead of a proton, which is direction of the force would be to the left, now it's going to be to the right. So we now have the force of the electron is going that way. And then we can do one more example when the magnetic field is coming out. So let me make these smaller. There you go, yeah. So you can still see them. And you have your electron traveling. Let's see. Let's do its velocity going downwards. So it's going to be coming out, and the velocity is going down, and so its force would be to the left. So we're going to do force is going to be this way. And this actually derives from the equation, which is magnetic force magnetic, equals Q, which is the charge, so it always matters if it's an electron or a proton, times the velocity times the magnetic field. And that is how you can use the right hand rule to determine in which direction the force is acting upon our atom in the magnetic field, which is going to be either a proton or an electron.